What's up, business class? My name's Royce, and today I'm going to be teaching you about nanotechnology. Nanotechnology is the manipulation of matter on a nanoscale, or 10 to the negative 9th meters, or the size of human hair. With nanotechnology, we can manipulate carbon molecules into tubes of multiple dimensions and sizes. Most single-walled nanotubes have a diameter of close to 1 nanometer, with a tube length that can be millions and millions and millions of times longer. IBM, the current leader in computer chips, announced a month ago that they were going to use carbon tubes to double the speed and capacity of their chips. Carbon tubes do not have to be single-walled to be useful. Each wall added to a carbon tube give carbon tubes different properties. A double-walled carbon tube can have resistance to chemicals, while multi-walled carbon tubes have tremendous strength. What makes this platform sturdy? Is it how close the atoms are to each other that gives the platform strength? No, not exactly. What gives things strength, flexibility, or other traits is its arrangements of atoms. These two items are made up of the same material, carbon. Therefore, they should have the same strength, right? Wrong, wrong, wrong. Charcoal is brittle because it has an arrangement of atoms that are in no particular form. The diamonds in this watch have a structure on the molecular scale that can distribute forces more effectively, making it much stronger than charcoal. But what if we could create a new structure? One that could take forces similar to what a diamond could withstand without the lengthy process needed to create diamonds. Multi-walled carbon tubes are most valuable for their strength. Not only are carbon tubes much stronger than steel, they're also much lighter, making them ideal building materials. Building up becomes a lot easier when you have carbon tubes. How tall can we build up to? For years now, NASA has been trying to come up with solutions to reduce the cost of taking materials to outer space. One idea that has been floating around for a while is to create a space elevator. The elevator would be tethered to the ground by a carbon nanotube rope, which would be the only material feasible to withstand these forces. Building a space elevator will reduce the cost of taking materials to space by a factor of 10. $12,000 per pound to approximately $1,200 per pound, which could in turn lead to greater space exploration for the private sector as well as the global scale. Samsung, like IBM, also wants to invest in nanotechnology. Samsung plans to produce TV displays featuring nanotubes. If successful, these screens can be lighter, brighter, cheaper, and more energy efficient than today's models. Companies are just starting to figure out how versatile carbon nanotube tech really is. They see the potential of this product. From super strong multi-walled carbon tubes to single-walled nanotubes that can hold more data than conventional computer chips, the possibility for this material is almost endless. With this being only one of the technologies that is possible with nanotube tech, it is safe to assume this might be the future for companies to invest in. Now, if you will excuse me, I have to go get in line for my space elevator ride to space.